right, next couple of problems did not copy over, so I am going to go ahead and just write them as we go. So the first one, we are doing the domain of our function, and the function is 6x over x plus 2, x plus 8. Okay, so the domain of the function is everything that, every x value that can be in the function except what makes the denominator 0. So what you want to do is you're going to take the values in the denominator, set them equal to 0. So x plus 2 equals 0 and x plus 8 equals 0. And then you're going to solve. So it's going to be an x equals -2, x equals -8. Okay, now those would make the denominator 0, so x cannot equal -2 and not equal -8. So you could say that x is all real numbers okay, with the caveat that x cannot equal, and then if we went in order, it would be -8 to -2 if we went least to greatest. Or, okay, or you can do an interval notation. So in interval notation, it would be going from -infinity, because we're going to go left to right. So -infinity to -8, and then we would go union, -8 to -2, and then let's see if I can move this. And then we would go union -2 to positive infinity. All right, next one we have, let's see, find the horizontal asymptotes, and the function is x plus 9 over x plus 8. All right, so this is case 1 where the degrees are the same. So remember, we're comparing the degrees. So this is first degree over first degree. So we're just going to take the coefficients, which are 1 and 1, and we're going to divide them. 1 divided by 1 equals 1. So notice here the domain, we had to deal with the x value. This one, we have y value. So the horizontal asymptote is always going to be a y value. In this case, it's y equals 1. Number 20, we have the function 3x squared plus 7x plus 6 over 2x minus 6. All right, so this is the case. The degree in the top is greater than the degree in the bottom. Top greater than bottom. Okay, in this case, there is no horizontal asymptote. So your answer there is that there is none. Okay, the case where the bottom is greater than the top, so let's say we switch those. Let's say we did a different color here. 2x minus 6 over 3x squared plus 7x plus 6. Okay, that would be the case where the bottom is greater than the top. Okay, there is a horizontal asymptote of y equals 0. So those are your three cases. They're either the same degree, you divide, the top is greater than the bottom, you have no horizontal asymptote, or the bottom is greater than the top, y equals 0. Now, in this case for number 20, when there is no horizontal asymptote, there will be a slant asymptote. Okay, the slant asymptote is also called an oblique asymptote. It's the y equals mx plus b line, and you're going to get that by doing synthetic division. So if I did this slant asymptote, let me see here. If I do 2x minus 6, so divide this, I would have, let's see, plus 6, 2x equals 6, x equals 3. So I would divide by 3 into my divisor here. Okay, so I would go 3 into 3, 7, and 6. And then we would do synthetic division. So bring down the 3. 3 times 3 is 9. 7 plus 9 is 16. 16 times 3, 32, 48. And then that would give you 54. But we can ignore the remainder there. So our slant asymptote is this. Y equals 3x plus 16. Okay, and that's all you have to do for that slant there. So you do the division, okay, so take that, if it's not in the form, x plus or minus something, just solve for the x, and then divide by synthetic division. All right, back to number 22. Let's see here. 21. The vertical asymptote is just, let's see, x over x plus 2. All you have to do for the vertical asymptote, it's the same thing as the domain. Just take the denominator and set it equal to 0. So x plus 2 equals 0 gives us an x equals -2. Okay, and then number 22, we've got, let's see, x over x squared minus 49. So we'll take the denominator and set it equal to 0. And let's see, add 49, x squared equals 49. We'll take the square root, and that'll give us x equals square root of 49 plus or minus 7. So you've got two asymptotes there, plus or minus 7, or you could say x equals -7, 7. Either one would be acceptable.